Hello guys, welcome back to the channel. Today we are going to solve this Leetcode question which is reorder list. And in this question we are given the head of a single linked list and the list can be represented as L0. L0 is nothing but the node 0, node 1 and so on, node n minus 1 and node n. And we need to reorder this list in the form of node 0, node n, node 1, node n minus 1, node 2, node n minus 2. We'll get a better idea after looking at the examples. If you look at these examples, we will be given with this linked list 1, 2, 3, 4, and we need to reorder this in such a way that first we need to have first node, then we need to have the last node, then we need to have the second node, then we need to have the second last node, right? And if you look at this example, first we'll have 1, second we'll have 5, third one is 2. Okay, I'll take a third one is 2, and the fourth one is 4, and the fifth one is 5. It's like first we'll take this, second we'll take this, third we'll take this, fourth we'll take this, fifth we'll take this, like this. Suppose if we have a length, we have a linked list of length 6. Let's look at the same example with 6. Suppose if we have a linked list like this, I'm extremely sorry. If we have a linked list of size 6, then it will be like 1, and then I need to have the last one, right? So it will be 6, and then I need to have the second one, 2, and then I'll have this one, 5, and then I'll have 3, and then at last I'll have 4, right? So this is the resultant linked list we need to return. So the question is easy to understand, but the implementation is it's tricky for me at least. And let's look how we can solve this question. So let's look at this example, guys, in order to understand how are we going to solve this question. So if you look at this, initially we need this, right? Initially we need this, and the second node is this, third node is this, fourth node, fifth node is this, sixth node is this, right? So if you observe the pattern, when we are going from left to right, for the first 3 nodes, we're going from left to right, and for the rest of the 3 nodes, we're coming from left to right, right? Sorry, right to left. Look at this, 1, 3, and 5 means I'll have 1 at the one position, and I'll have 2 at the third position, and I'll have 3 at the fifth position, and I'll have 6 at my second position, I'll have 5 at my fourth position, and I'll have 4 at my sixth position, right? So for the first half of the nodes, we're going from left to right, and for the second half of the nodes, we're coming from right to left. Yeah, right to left, right? So the thing that came to my mind is that initially I'll find the length of the entire linked list. Initially, I'll find the length of entire linked list, and what I'm gonna do is I'll find the half n by 2 value, and I'll traverse through the till the middle, and then after coming to the middle, I'll store all of these nodes in my stack. So if I use a stack, it will be like first I'll store 4, then I'll store 5, then I'll store 6, right? So in this way, I can access the element which is at the last, right? So after storing these like this, what I'm going to do is I'll again, I'll break this link. From here, I won't have these nodes since I have stored them in my stack. Right? Now what I'm going to do is initially I'll place a pointer here, and this is my top, right? So initially I'll take 1, then I'll take the top value 6, then I'll take the 2. When I take 6, 6 will be removed from the stack, right? Then I'll take 5, When I take 5, the 5 will be removed from the stack, right? So, and then after 2, I'll take 3, and at last I'll take 4. So this is what I got into my mind, guys, in order to solve this question. And it did work when I tried it, but it's a really, really long process in order to solve the question in this way. So I tried to optimize it by, and I tried to optimize it because the space complexity is order of n, right? I thought, we can rearrange these elements, by just playing with these links. You know what I mean? So I tried to get this answer by just interchanging these links. So I tried how can I do that, and I finally got a solution. So I'm going to explain that solution right now. So I'm telling you the second intuition, a second approach. So in this approach, it is just the same idea, but I'm just implementing it in a different way. You know, what I have already said, like I'll find the length of the linked list, which is 6. I'll find the half. I'll go till the half, and I'll break the link. But now I'm not going to store the rest of the values in my stack. Instead, what I'm going to do is I'll break this link, and what I'm going to do is I'll take these nodes. I'll make them a new linked list, which is list. Let's say the list 2. This is list 1. Let's say this is list 1. This is list 2. Now what I'm going to do is I'm going to reverse these. Right? It's the same as using a stack, right? But here we're not even using an extra space. 6, 5, and 4. So if you observe carefully, we just did the same thing but without using a stack. So now how am I going to merge this into a single linked list so that we'll have the resulting linked list? So if you observe carefully, we just need to add one by one. First I'll add 1, then I'll add 6, then I'll add 2, then I will add 5, then I will add 3, then I will add 4. So this is the linked list, resultant linked list, right? So this is the most trickiest part in this question. So how are we arranging these two lists into this? So let's look at this with an example. Now this is my linked list 1, and let's say L1, and this is my linked list to L2, right? So what I'm going to do is I'll take a pointer which is let's say PDR1 or P1. I cannot write with this mouse, so I'm just writing P1 and P2. So what I'm going to do is I know that after 1 I need to have 6, right? So I'll just break this link and I'll join it to this, right? But if you observe carefully, if I break this link, I'll lose the track of these two nodes. So in order to keep the track of these two nodes, before breaking this link, I'll mark this as N1. N1 is nothing but next one. You know what I mean? So before it will be like this. So I'll mark this node as N1 before breaking the link. So after marking this node as N1, I'll just break the link and I'll make sure I'll it will be pointing to this node, right? Now after 6, I need to get 2. So I'll just break this link and I'll point this link to this node, right? But if you observe carefully, we're losing track of these two nodes when I do this. So before doing this, it will be like this, right? So I'll have a pointer to this node which as n2, right? And then I can break this node. I'm sorry, I can break this link. Then it will be pointing to this node because I'm also having the access to these nodes, so it will be fine. Now, what I'm going to do is I'll repeat the same for these two as well, right? Now what I'll do is I'll remove these two and I'll make this as P1 and I'll make this as P2. The same thing repeats for each and every node. So before breaking this node, I'll mark this as N1 and I'll break this node, break this link. I'm sorry, break this link and I'll make sure this pointer points to this one, and then this this link should point to this one, right? This node should point to this one. So before breaking this, I'll make sure I'll add a label for this, and then I can break it, and I'll do something like this. After doing this, I'll just move my pointers. This will be my P1, will be my P2, right? Now again, it will be pointing to, initially it will be pointing to null, right? So my N1 will be null, and after labeling it, I'll make sure I'll point this to this one, and my N2 will be null, right? N2 will be null, and I'll make sure that I'm point this to this. This link will be broken, right? I'm sorry. Yeah, it will be like this, and then the next step, my P1 and P2 will become, my P1 will come here, and my P2 will come here. So this is the approach, guys. So we'll stop when either P1 or P2 becomes empty. But we need to handle a, you know, we need to take care when there are odd number of nodes. Suppose we have something like 1, 2, 3, 4, 5. Suppose we have odd number of nodes. We need to make sure that the first list has the, the additional node so that this process will work. And the second list must only contain the n by 2 minus 1 nodes, by 2 minus 1 nodes, right? The additional node should be on the left, on the first linked list. So we need to take care of this base case, sorry, corner case, and let's try to understand the code. I just wrote the code right now. I can write it, but yeah, that's fine. I cannot write it once again. So initially, I'm having a function called length. This is the function length, which gives me the length of the linked list. I'm storing it in count, or you can also store it in length variable. If the count is less than or equals to 2, I'm just returning. Suppose if I have a length of 2, for the resultant linked list, I need to have 1, and second, I need to have 2. It's the same linked list, right? So when my length is less than equals to 2, I'm just returning. I'm not doing anything. Now, skip. Skip means nothing but, as I have already said, we'll be having 1, 2, 3, 4, 5, right? Suppose if I have 5, you know, I need to I need to break this link, right? So I'm skipping two values, that like that. How many values I'm skipping means count plus 1 by 2 minus 1. Suppose if I have 5, if the length of the linked list is 5, 5 plus 1 by 2, which is 3, which is 3 minus 1, which is 2. So from here, I'm skipping 1, 2 steps, and I'm going to reverse this, right? So um, I'm skipping two times, and after skipping two times, I'm marking the rest of the linked list as list 2, right? And I'm making sure that pdr.next equals to null. My pdr will come here, and I'm making sure that I'm breaking this link. I hope you are understanding what I'm saying. And what I said, after breaking this link, we need to reverse this linked list, right? So I'm just reversing. After reversing, the head of the linked list is reverse linked list 2, right? Now, as I already said, this is P1, this is P2, right? Before reversing these links. So it will be like this. This will be pointing to this, pointing to this, will be pointing to this without any in between links, right? So it will be like this. So PDR1 is the P1, and PDR2 is the P2, which is the reverse linked list 2 head. right? This is the reverse linked list head, right? Now what I'm doing is while PDR1 not equal to null and PDR2 not equal to null, while these two are not equal to null, what I'm doing is what I said, I'm going to mark this as N1, right? Look at this. I'm going to mark PDR1 dot next as next one, and I'm going to mark PDR2 dot next as next two, right? And what I'm doing is P1 dot next equals to P2, right? So I'm doing the same. PDR1 dot next equals to PDR2. And what I'm going to do here is PDR2 dot next equals to this is N1, right? PDR2 dot next equals to N1. N1 is nothing but next one. Now I'm moving my PDRs to here, right? So my PDR will become PDR1 will become next one, and my PDR2 will become next two. Right? My PDR1 will become next one, and my PDR1 will become next two. That's it. And at the end, we don't even need to return anything. They'll just, they're asking void to. We don't need to return anything, right? They'll just use the head of the linked list that they have provided us. They'll use this link. Since we have modified it like this, it will run fine. I have already submitted it and it ran fine. So this is the code. Right? That's it guys for this video, and if you find the video helpful, like the video guys. Thank you.